Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Got some PCBs here. It's for the VBE multiplier or bias spreader board for the 200 watt BTL amplifier. So I've got 20 of these. I only need 2, but considering they're only $5 for the production, I thought, well, I'll get 20. So I'll open the bag and try and get this lot out because, well, they include this Sika gel crap which you're supposed to throw out. In fact, I'm just going to throw the whole lot out because I don't really need the plastic bag that this came in. So here we go. There they are there. So I'll just take one out. I need 2 for this project, so the other lot can sit to the side. So I've designed this so the BD139, which is what it's going to be, it can be really any TO126 transistor for all it mattered. I designed it so that the transistor mounts or solders on the underside, the copper side of the board. So if you picture this side on, we've got the components on this side, the variable resistor and the 2 resistors. Transistor on this side with a spacer in between, and then that would go into a threaded portion on the bracket so it can actually mount from the top onto the bracket in between the 2 output transistors. I'm going to be using some 6mm spacers, these Duratec brand, which is HP0860 from JCar, so they're non-threaded 6mm spacers. And I worked out that visualizing that the PCB is like mounted that way, right? So there's the screw. You've got the board thickness here of 1.6mm, the 6mm for the spacer, 2mm or so for the transistor body, so just grab a transistor for reference. So like, you know, that. And then the 3mm of the bracket, and this with the 15mm screw, it should just be long enough to thread in, but not too long enough to poke out onto the other side of the bracket, putting tension on the board, because I can't really drill any holes through the PCB because there's traces that run on the other side. So even if there's like a extra millimeter overhang on this bolt, I can add a washer on the head side, maybe, just have enough room, or I could put it on the underside, I suppose, just to take up the space, and hopefully that will work okay. So I'm going to just show you how this is going to be implemented. So in the current amplifier we have the positive voltage rail, which goes through a constant current source, which is 2 resistors and the capacitor to the output forming bootstrap, but we won't show that for clearness. Then it goes through 1N4004, and it goes through the second 1N4004, and we end up at the VAS transistor to the negative rail. So that's the VAS. This one goes off to one driver, and that goes off to the other driver. Okay, so what I'm going to do is we're going to eliminate these 2 diodes. So to redraw it, we've got excuse me, the positive voltage rail there, a constant current source, and that goes off to one driver. So now we go through one resistor, a second resistor, a variable resistor, this point here goes to a BD139, that collector gets connected to that point, and sorry, ignore that, this emitter gets connected to that point, and that goes to the VAS transistor. So this value is 1K, this is 220 ohm. The reason this resistor is here is in case this pot is rotated fully so it's 0 ohm, that it's not bringing the base directly down to, well, the VAS transistor, causing it to be close to the negative voltage rail, which will put the bias current way up there, probably a few amps. So it just limits the current to the output stage to protect it. This value is 1K, and this part goes off to the other driver on the other side. So that's basically what we're doing, is we're eliminating these two diodes, including this circuit, and making an adjustable current with this trim pot. And that's basically it. The way I'm going to do it on the circuit board is, the first diode here is open. It's got plenty of access room to get two wires in to connect it to this board. This diode here is buried under the two degeneration resistors of the output stage, so I'd have to remove those two resistors to get to it. But what I'll do is I'll take that diode out and I'll put in a shorting link wire in its place. Then put the two resistors back in, and then the wires for the VBE multiplier, eliminating that diode, go between those points. And positive going towards the positive rail, negative going towards the negative side, which are marked on the board here, positive, negative anyway. So that's how that's going to be put in. So how well this works in practice, we're going to find out. So sit back, enjoy me with my frustrations, trying to get this to work, which means I'm going to have to pull the power amp back out of the case off the heatsink. I've got to pull the bracket back off the board to drill two new holes to tap it. But before I do the tapping, I'm going to do modification on one of the channels, the left hand side, include one of these circuits and see if the bias is adjustable and nothing goes off with smoke. And once it's passed that test, I will then implement the second side and test that out separately as well, and then I'll make sure both amplifiers play nice with each other in bridge configuration. So we'll get doing that. And I apologise for my crudely drawn drawing here. Yeah, it is what it is. But anyway, let's get doing something more constructive. Okay, that's what I was going for. Now, you can see with the spacer here, my measurements were a little off. So what I ended up doing was I ended up using the bushing that comes with the isolator kits with transistors. I cut the little bit that slips through the TO220 device, the little, I don't know what you want to call that, recess. So it's now a flat washer. I've also got an M3 washer on the other side of that before the body of the transistor. And that leaves me just around about 2.5 millimeters of thread sticking out the back. I haven't accounted for the width of the isolator, but I reckon there should be just enough threads to screw this into a threaded hole on the heatsink bracket, and that's what I'm going for. I've also built the second one the same way. Those nuts will not be there. They were just there to hold the transistor flat prior to soldering. So now I have the fun task of attaching these to the amplifier. So to save pissing about, bit of dust, I've got to remove the module out of the amplifier anyway to do this. So I'm going to go for broke, and I'm going to actually pull the bracket back off of the heatsink and off of the PCB. So I can work on the PCB out of the unit. And I'm going to just drill and tap the holes I need for those VBE multipliers anyway, and then put it back together and remove these degeneration resistors so I can get the diode out underneath, and put a link wire in, put the resistors back in, take the other two diodes out so then I can run wires from the VBE multiplier into where the diode goes, and then we can proceed with testing, because it's got to come out anyway to make the modification. I'm pretty confident that it's going to work just fine, so might as well do it. It just means I've got to take it all back apart, but I think I can get my bendy screwdriver in there. And by bendy I mean this thing. Oh yeah. Alright, so let me get to pulling this apart, and I'll come back in a second. There we are. So, whilst I have it apart, I'm probably going to remove this ground wire over here, which doesn't seem to work properly in that position. I may try actually soldering the ground wire, which is here, over to this capacitor's center point, because this is the ground of one capacitor and that one over there is the ground of the other side. So if I put it onto this side over here where the ground is, which I believe is ground, it should be ground, there's no trace on this side, so I would assume it'll be ground because all the traces for ground run on the top side. I can verify that. That should connect between here and here, which it does, and it should also connect to here, which it does. So I can try putting the wire here, because it's more closer to the center of the capacitors, and further away from the center tap of the transformer up here. I don't know if it's going to make any difference, but I do know that grounding it from over here at this ground pin seems to cure the problem. But you're thinking, why would I, modify this to include the BBE multiplier and just changing the ground to see if that makes a difference rather than just rerouting the PCB? Well, because it's expensive. This PCB for 5 pieces costs nearly $100 Australian plus the shipping, and then there's probably like $150 odd worth of components on this PCB, the output stage being $30 alone. Well, 60 actually, because it's 15 per device. So probably over $150 worth of parts, like $200. And I don't really want to have to spend extra money if I don't have to, because I can just make this modification and it'll fix the problem. So what I need to know is I'm probably going to put my screw holes in line with the screw holes for the output devices, because this is about the same size as the transistor. Almost dead replica for it. And luckily, if I screw up with my tapping, there are no traces running where these screw lines are, except there's the PCB way logo there, so I'd end up drilling a hole in the PCB through the logo if I have to drill a hole to put a nut on. I want to try and avoid that, so I just want to tap in here and in here. So this bracket's going to have to come back off. I'm going to have to mark it out with tape, center punch it, and then drill it with a pilot hole, and then tap it to M3, and then basically reassemble it. Alright, here we go. Alright, so all the screws removed. Let's see what gives way. It should give way. There's one. I don't want to start prying with screwdrivers or anything if I can. There goes another one. Avoid it. I'm trying to hopefully leave the sill pads stuck to the device. Shit. Rather than the bracket. Oh, that worked out perfectly. All the sill pads have remained stuck to the devices. That can never happen, no matter how hard you try, ever again. Oh, awesome. Alright, okay, so that made that job easier. So now I can clean up the bracket once I've finished. So our output devices are here, so the center between the two is here. So I can't remember the measurements offhand. So if I put the circuit board over to the left of me. Alright, it was 35. 35 between the centers, so that means I have to go 17 and a half, I believe, to go in between the middle of those two. and the other's 35 as well. Okay, so let me get some tape on this and mark it out. What's the distance between here and the edge, just out of interest? About 15 and a bit. I'm going to say 16. Yeah, something like that. Alright, I'm going to mark this out with tape, center punch it, drill it, and then tap it, and then put it back together. Right, well, that was easy. It's drilled and tapped now, and the screws go in straight, so that's all I'm concerned about. It's also deburred. So one screw goes in straight. That's not the screw that's going to be used, by the way. It's just a screw that I had to hand. Same with this one. If I can get it started, it will thread in straight. Well, semi-straight. It's not perfect, but yeah, that's what it happens when you use hand tools. Nothing is like perfect. But the VBE multipliers themselves, if I now get rid of this nut that's holding the transistor together, and now bring this up to the device. Yes, there's no isolator yet, but there will be. I just want to see with it almost tight. Got to be careful not to over tighten this because I'll strip it out. Let's get it tight enough. Oh, there's barely any screw head sticking through, so that should just work fine. Alright, now to reassemble this back onto the PCB. So this should be relatively easy to do, so I'm just going to bend up each of the devices just a tad to give the bracket room to slip under without ripping the pads off underneath, the sill pads. Alright, so I'm going to get two things. First that, so I can start lining it up, and that for the temperature sensor, so I can start lining the bracket up with the transistors. I'll get a nut on the back of that one, this handy little nut that's just lying around. Okay, so I'm going to start with this N transistor, because that'll pull the bracket straight, or in line I should say. And then it's just a simple matter of putting all the screws back in and nuts and then tightening it. But I seem to be missing two 20mm long M3 screws. They're on the desk here. I didn't put them in the pot when I was playing around with the threaded holes. Okay, so I'm going to have a nut left over because I had a spare one off of the VBE multiplier. So the next thing I'm going to attack is removing the degeneration resistors after I've got this bracket tight again, and getting those diodes out from underneath. So I'll just start tightening things down. So yeah, let me get this all tightened and we'll come back in just a few moments. Right, I'm just going to do a continuity check between the transistors and the heatsink bracket just to make sure the collectors are not actually connected to the bracket, because that would be bad. Nothing. 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 Okay, so that's good. Just mainly I was concerned about, because I pulled these transistors on and off several times using the same sill pads, that it can become or they can become deteriorated and not insulate properly anymore and cause shorts, but there doesn't appear to be any. Alright, so the next thing to do is to remove these sets of degeneration resistors and apply some length of wire, appropriate length of wire to these VBE multiplier boards to go into this position. I want to keep the wires as short as possible and twist it together. So let me get about removing these resistors, which will be easier than trying to remove the diodes, and then I'll show you what I'm talking about in just a few moments. Okay, the parts are removed, so all the diodes are removed. The resistors are removed and so is the diode underneath. So all I have to do is take a piece of link wire that's fashioned the right way and put it in place of this diode that's hiding under the resistors on both sides to complete the circuit there. And yeah, we'll be good. So I'll get to soldering that. Shit. Didn't do any damage. Alright, let's see. Just trying to make sure it's flat. Because I thought it would be easier to link the diode underneath the resistor rather than running the wires underneath the resistor, because that's a source of heat and I don't really want the wires warming up, if you know what I mean. So I want to keep the wires well away from those resistors so they don't burn them up. Okay. Let's trim off any excess that's there, which won't be much because I pretty much measured it to how much I needed rather than wasting that tin copper wire, because it's like $17 a roll for this stuff. Like $17 or $18 for a roll of this stuff, maybe more. It's WW4032, that's the one I use. It's 0.8mm, well actually 0.71mm tinned copper wire, 22 American wire gauge for those of you playing at home. Yeah, so it's quite expensive from J-Car, but anyway. That's the link wires put in. That one's albeit a little bit all over the place. Let me see if I can push that through any further. Not like that, I can't. Probably not going to worry about it too much. It's going to be hidden underneath the resistors anyway. Let's retouch up that joint I messed with. Okay. So now I can put the resistors back in, and then I can start thinking about mounting the VBE multipliers. Well, that wasn't difficult at all, he says, as he struggled with it for half an hour. It was mainly messing around with these wires, getting them to go where I wanted them to go was more of the issue. But both VBE multipliers are in. Now, as long as they're routed correctly, nothing should blow up. But I'm going to put it back into the amplifier's case, and I'm going to do one module at a time. So I'm going to remove the fuses out of one channel and do one channel at a time on the dim bulb, just to make sure that you know, it can be adjusted and it's actually functioning and it's not going to go off with a bang. So let me get this back into its case and we'll have a look at my enormous... Alright, let me get to doing that. Board's back in its home. Oh, for fuck's sake. I think the battery's going flat too. I got the multimeter set to voltage DC across one of the degeneration resistors on that side. So I've calculated ahead of time what we need to see on the multimeter. I need about 15 millivolts for 31 mA of current draw on the output stage. So I'm going to turn the dim bulb on, nothing's bypassed. Here we go. Nothing unusual, and we've got 100 odd millivolts so far. Relay engaged, so we've got no DC offset. See if we can adjust. Yes, we can. I'm going to adjust that right down to 15 millivolts, and that'll be roughly 30 mA. 15 millivolts, so 30 mA, it just creeped up a little bit. So I'll go on to millivolt. So we're more like 18. It's going to rise as the amplifier starts to stabilize. So we can back that off a little bit further until we're back at around about 15 millivolts. That's probably where I'm going to leave it. And then I'm going to leave it for 5 minutes and see if it stabilizes out at around the 15 to 17 millivolt range. So after about 5 minutes, it seems to have crept up to probably about 45 mA. But that's fine, I can adjust that down. You've got to let the amplifier stabilize before you do the final bias adjustment anyway. And I think that's the end of my travel of the bias, because it's not decreasing any further. So that's the end of the travel of the pot, unfortunately. Okay, so I'm going to have to go for a slightly higher bias. So I'll make that about 25 millivolts. Okay. I think the amplifier is going to be happy at that bias point anyway, which is around 53 mA, which is, yeah, okay, that's probably on a little bit on the high side, but it's okay for what this is going to be doing. It's a lot better than 168 mA. Let's just get that straight there. So now I have to do the same to the other channel, and then I can connect it back up to a load and oscilloscope, and we'll see if we still got an output. Load is hooked up, so is the oscillator. It's a little bit more awkward now with the connectors for the speak-on connector connected, but whatever. We do have an output, so I've got the other amplifier biased, but the thing is, that seems to be biasing higher than that one, so I could only get that down to about 30 millivolts, so it's sitting around about 34 millivolts now, so that's closer to 75 mA. But it is what it is. I've checked my work, the resistors values on that are correct, so I don't know what to tell you. So I'm going to bypass the dim bulb. I'm going to wind this up until we get to clipping and see if this thing's going to go off with a bang. Hopefully not. So I'm winding it up. There's clipping. We're pushing 33 volt RMS. So 33 volt RMS, or 32.8. Turn that down. Bit of heat went into the heatsink, but not much. And we're still at 136.125 watts into 8 ohms, which is good enough. I've moved my ground wire to this filter cap's positive, I think it is. Whichever one it is, whichever side is ground. The wire is just long enough, so now I know it's safe to actually plug into the wall directly without things overheating or exploding. I can get rid of the dim bulb and plug it in directly, and I'll hook it up to a speaker now. I just want to see if we still have that mains noise earth issue. Right, got it set up. It's now off the dim bulb and it's connected to the wall directly. The preamp's connected to the power amplifier input. So I haven't got a ground connected anywhere yet. I want to make sure there's no unusual noises, which there's not. So let's touch this ground. Nah, it's still doing it. Well, that's kind of annoying. Alright, so I'm going to have to go back to my original idea, which is taking the ground off of that ground point just there next to that resistor, or just ground point here actually, next to that capacitor. Because, yeah, that's frustrating. That's fine. Okay, so the next thing I want to do is, I've got the pot for the fan speed, or fan temperature controller, set to about 3/4. I want to get this amplifier running at half power until we get some heat into the heatsink, so that's about, I'm going to say, 17 volt RMS thereabouts. Get this heatsink nice and hot until this fan kicks on and see like if it, you know, does what it's supposed to do. Those are red hot. Ooh, it's actually starting to ramp up. Alright, so I'll kill the oscillator, and as that's not producing any output now, everything should start cooling down. Which means the fan should start slowing down. And the fan is starting to slow down. And the junction temperature of those two sets of transistors has cooled off. So the VBE multiplier is doing what it needs to do. And it's now running at half its bias, as it was before. So I'm going to say that, yeah, that's okay. Those drivers were getting warm too. And that heatsink for the 12 volt rail is pretty hot. But it will be. And now the fan has almost stopped. Isn't that cool? Pun intended. So that means I'll need to put a dob of heatsink transfer compound just on the NTC here, because if I touch it the fan will start back up again. Well, maybe not. Just to, you know, help with heat transfer into the NTC. But that bracket has cooled right off and is about the same temperature as the heatsink now. So okay, my ground's still an issue. I'm not sure why I can't get any lower than about, I think it was 26 millivolts before the pot trouble runs out on this channel compared to this channel. Might be tolerances of components, I'm not sure. May have to increase the 1K resistor to something a little bit higher so I can get a lower bias setting. I don't know. Leave your thoughts below. So that's going to do it for this video. Hope you enjoyed it. If you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya. Have a great day. Fan lol.
Amp it up, let the music flow. L's got the magic, come and see the show. Experimenting with wires, making sound divine. When things blow up, we just laugh, that's fine.